Good day, dear colleagues. Our report, Energy Evaluation of Technologies of Fallow Lands Cultivation at High Humidity depending on degree of weed infestation. Existing problem. The exclude the agricultural lands from crop rotation is leading to its weed infestation. Russia has largest land resources in the world, 120 million hectares of tillage land. But at present, up to 40 million hectares and withdrawn from calculation. In the first year, the non-cultivated field is overgrown with annual and perennial weeds, which form a powerful sod. Then shrubs and trees begins to appear. In the northwest region of Russia, these excesses are more expressed because of high humidity. Further excluding of agricultural land from agricultural use can lead to a decrease in the efficiency of the remaining agricultural production. The northwest of Russia is included in the zone of high humidity and plays an important role in providing the population with food. The restoring of uncultivated land is an important resource for increasing agricultural production and a factor of a food security of the country as a whole. Since 2012, the authors have been developing technical means and technologies for the fallow lands, the cultivation at the high humidity. As a result, the following are substantiated. The system of technological processes and technical means, the principles of the formation of a zonal system of soil cultivation, the energy efficiency evaluation of various technologies for the fallow lands recultivation. At the same time, new technical means and technologies are being developed for putting uncultivated lands into agricultural use, depending on weed infestation. The aim of studying energy intensity evaluation of technological processes and technologies for the fallow lands recultivation at high humidity. The research was carried out in the fields of the production and experimental base, burdened for 6 to 12 years. Experimental conditions are as follows: soil moisture 12 to 4%, pH height 25 50 centimeters. Average number of plants 420 and 756 per meter. Soil type should slightly podzolic. Soil hardness before processing in layers 0 and 10 centimeters. Results. The selection of the method and technical means of fallow land cultivation is determined by agroclimatic features, vegetation cover, type and granulometric composition of soil, and other agrophysical properties. As a rule, the choice of design and technological parameters of machines, performance features of machines and tractor units are influenced by natural and climatic conditions. This includes the physical and mechanical characteristics of the soil, the working length of the path, the file width, roughness and relief, the ambient temperature, precipitation. At the high humidity, the root system of plants usually will develop to increase the soil moisture absorption. In general, the mass of the root system often exceeds the aerial parts of plants. The root system covers a relatively small volume of soil, but use the most of the soil moisture thanks to the very dense branching. In the wet zone, a very thick sod can be formed depending on the humidity and soil utility. Sod is onogromedial humus accumulative surface soil horizon, formed under grass, mainly middle vegetation. Long-term agronomic practice shows that the type of the soil can be determined by the vegetation cover with a high probability. Figure 4. Taking into account these agroclimatic features of the wet zone, we have determined the main requirements for technological processes, technologies, and technical means of fallow land cultivation. Technology should ensure the shortest possible introduction to fallow lands with minimal energy and money costs. Technologies and technological processes should be flexible. It means quickly resetting the machines for a new operation or process, soil protective and environmentally friendly. At the same time, the technical means should be universal, allow the machine most operation at all stages of work in typical conditions of high humidity and uneven relief, with a relatively small area and rugged outline of fields and limited period of work. Be equipped with working bodies with safety systems that ensure the protection against breakdowns with working in the rocky fields. The systems should be high performance and reliability, have good mobility and transportability, ensure energy efficiency. Technologies for the fallow land cultivation and the high humidity should be include technological processes that meet the following criteria: soil protection, quality of performance of technological operations, minimum energy intensity, minimum cost, the maximum reliability coefficient, environmental safety. Fallow lands can be classified according to the fragility, width, infestation, and soil type. Figure 5. Our studies have shown high efficiency of the universal combined tillage unit EQPR 2 and 4 in various modifications developed at the AIAE. It works with a various version of technologies for the fallow land cultivation. The EQPR 2 and 4 unit with reaping working bodies, geared to 1 and 4 ton plus tractor, can be used for the soil closing without turning the layer to a depth of 12 or 15 centimeters into treads. The EQPR 2 and 4 unit with duct put on elastic stands can be used for soil cultivation to a depth of 12 or 15 centimeters. 3-4 days after the soil layer is decompressed with the EQPR 2 and 4 unit with reaping working bodies. The EQPR 2 and 4 modifications equipped with circular working bodies fixed on spherical discs is intended for surface cultivation to a depth of 5 or 10 centimeters for reaping and leveling the field surface with simultaneous leveling of wheat roots. Based on our own experimental research, analysis, and computation of material from other scientific institutions and research, we have formed the system of methodological processes for the restoration of uncultivated lands. The system was developed according to the degree of wheat infestation at the high moisture and based on the above classification of fallow lands, figure 5, and criteria for assessing efficiency. The energy cost for each technology option and determined and given in tables 1 and 3. Thus, a considered technological can be represented as that of production operations in a certain sequence as a result of which fallow lands will become suitable for agricultural use. Figure 9. Graphical interpretation of energy consumption for the illustration of fallow lands recultivation depending on weed infestation. 1. Fields overgrown with trees, shrubs, and perennial weeds. 2. Fields overgrown with small shrubs and perennial weeds at height of herbage above 40 centimeters. 3. Fields overgrown with perennial weeds and height of herbage up to 40 centimeters. The calculation gives in tables 1 and 3 and figure 9 shown. The recultivation of lands overgrown with trees, shrubs, and perennial weeds on average needs 7,241 and 9 MJ of energy per hectare. The cultivation of lands overgrown with small shrubs, perennial weeds at a herbage height over 40 centimeters need an average of 4,572 and 6 MJ per hectare. The cultivation of lands overgrown with perennial weeds at a herbage height up to 40 centimeters needs 3,818 and 8 MJ per hectare. The example of a cultivation considered is the article intended to illustrate energy consumption on various technologies and to mark the futures of measures for recultivation of fallow lands depending on weed infestation. Experimental studies have shown that the technical means developed in the AIAE are quite universal and convenient for use in technologies for the fallow land recultivation. Due to exceptional variety of factors, methods, techniques, and technological operations encountered in practice that affect the result of the operation of technical means for the primary cultivation of fallow lands. There is currently no way to offer a single universal set of technological processes and technologies. The selection and sequence of operation and technical means depend on the structure and soil and climatic conditions for the implementation of technologies. Thanks for attention.